Hi everyone, in this video I am going to explain about the Servo Potentiometric type digital voltmeter DVM. We will learn its working principle and how it accurately measures the unknown voltage using the servo control balancing mechanism. This is a very important topic for the students of EEE as well as those who are preparing for the competitive exam. If you find this video helpful, please like, share and subscribe to my channel for more education content. Let's get started. Servo Potentiometric type DVM. In this potentiometric type voltmeter, internal reference voltage is provided. The internal reference voltage is denoted as Vref. The voltage to be measured is the input voltage and it is denoted as Vin. A voltage comparison technique is used to determine the input voltage. The unknown voltage is compared with the reference voltage with the help of a dial setting of a calibrated potentiometer, that is potential divider. The arm of the potentiometer is varied to obtain the null condition. Practically, the balancing is not obtained manually, but it is obtained automatically. Such a potentiometer is called the self-balancing potentiometric type DVM. The servometer is also used to vary the arm of the potentiometer, hence it is called the servo balancing potentiometric type DVM. The internal reference voltage is present at two terminals of the potentiometer. When the null condition is obtained, the value of the unknown voltage is indicated by the dial setting of the potentiometer. The input voltage to be measured is applied to one side of the mechanical chopper type comparator after filtering and attenuating to suitable level. The reference voltage is applied at the two terminals of the potentiometer. The position of the sliding contact decides the value of the feedback voltage, which is used as a second input to the comparator. The comparator, which is an error detector, compares the unknown voltage and the feedback voltage. The output of the comparator is always a square waveform whose signal amplitude is a function of the difference in two voltages connected to its end. This output signal from the comparator is amplified and then fed to the power amplifier. The power amplifier output is given to the servometer, which acts as the potentiometer adjustment device. The potentiometer and the servometer moves the sliding contact proportional to the error signal. The direction of the movement of the sliding contact depends upon the sign of the error, whether the feedback voltage is larger or smaller than the unknown input voltage. When the feedback voltage is same as the input voltage, the error is zero and therefore the servometer will not receive any signal, which will stop the movement of the sliding contact. Thus the sliding contact will attain a very stable position. And the voltage corresponding to the stable position of the sliding contact is indicated in the numerical form on the digital display. Vin is equal to X Vref. This is the relationship between the unknown input voltage and the reference voltage, and it can be mathematically expressed as. Here, Vin is equal to voltage to be measured, Vref is equal to a reference voltage, and X is equal to fraction depends upon the position of slider. The voltage to be measured depends upon the reference voltage, as the maximum value of the fraction X is 1. The reference voltage source used in such DVM must be extremely stable, and generally a standard cell or a Zenza diode is used as a reference voltage source. Thank you.